Hello everyone, I'm Shanri. Today we are going to talk about the NP question. Class NP is a set of language which can be verified efficiently. So here efficiently means in polynomial time. If we want to verify something, we need a verifier. So I will give the definition of the verifier. Verifier essentially is a Turing machine. We name it V. So if the input string X belongs to the language, there exists a certificate, which I will cover it later. Make the verifier accept. So if X does not belong to the language, so for all the certificates, the verifier will fail. So they will give a reject on all the certificate. So the definition of certificate actually is just additional information. Used to check whether a given string X belongs to the language. So the definition is really trivial. There's one thing important to note, that the length of the certificate should be polynomial with the input size of the string. The reason the constraint exists is that we need to verify efficiently, as I mentioned before. So if we cannot read the input in polynomial time, it's impossible to verify efficiently. So this constraint is very important. If we want to prove some languages belong to the NP, we first need to pick the certificate which is polynomial with the input size of X. Next, finally, we can get to the definition of efficiently verifiable. We see that language is efficiently verifiable if there exists a verifier, as we introduced before, that verifies the language L efficiently. So after introduce this, I will give a specific example. There's many special graph structure. There's one thing that called k-clique, means it contains a subgraph that also, first of all, the graph should be undirected graph that contains a k-clique subgraph. So k-clique subgraph basically is a subgraph that have k nodes and all the k nodes are fully connected. Like if we have 4 nodes and they are fully connected, so we can call it a k-clique. So next we want to prove the clique, the language clique is belongs to NP. So how can we construct the proof? As I mentioned, firstly we need to pick a verifier and a certificate, then prove it if it is efficient, and finally we can got an answer. So what's the certificate here? If we choose certificate is just the subgraph k-clique itself. Next, the verifier will be defined as follows. The verifier equal to on input G, K, and my certificate, which is k-clique itself. And firstly, I will test whether C is a set of K node in my G. So if not, we can just reject it and output the result. Else, we will proceed to step 2. Step 2, when you test whether all edges are contained in G. All connecting edges in C are contained in G. It's also trivial, since we want to prove that C is actually a k-clique. So if G does contain, we just accept, and if else, reject. One thing I want to mention is that since C is a subgraph of the G, so it is sure that it's polynomial with input sides. Yeah. Then we should analyze those 2 steps are efficient. We can see that whether C is a set of K nodes in G is linear of the number of nodes. Then the second step, checking whether G contains all connecting nodes in C, is linear of the number of edges in G. So we can see that 2 steps are efficient. With respect to G. So that's all for today. Thank you for listening.